All right, so today we're going to take a look at two ways of doing the exact same thing, finding the distance from my classroom to the cafeteria using two methods, okay? So Pythagorean theorem is going to be my favorite. To be honest, the distance formula comes from Pythagorean theorem, but I don't have the time to show you at this very second. However, Pythagorean theorem is what I like to do, but I will show you both because distance formula is once you know the formula, you just plug it right into the calculator. Okay, so use Pythagorean theorem to find the distance between these 2 points. So let's use Pythagorean theorem first. We're going to plot the point 2, 7. So 2, 7. And then we're also going to plot -1, -1, -4. And we are finding the distance between these 2 points. Okay, that's how we're finding it. Whenever you're using Pythagorean theorem, the very first thing you're going to do is make a right triangle. So you can do that two ways. You can do it like this, or you can do it like this. So whichever way does not matter. So I'll just go straight up and across. Okay, I made a right triangle, so I can use Pythagorean theorem. To use Pythagorean theorem, all right, it says a squared plus b squared is equal to c squared. Okay, where c is always your longest point. All right, so your longest side, which is always going to be opposite the right angle. Okay, so this longest side is always opposite the right angle. A and B does not matter. So I can say this is A, or I can say that's A, or I can say this is B, or that's B. Doesn't matter. Okay, as long as C is always across from the right angle. All right, so how many boxes are this? You can count them, or you can say 4 to 0, that's 4. 0 to 7, that's 7. 7 plus 4 is 11. So there are 11 boxes here. If you don't understand what I'm doing, go ahead and just count. All right, this is 3 across. All right, so a squared, I'm going to say, doesn't matter which one I use again, okay? So it's going to be 11 squared. I'm using this is A, and this is B. So plus 3 squared is going to be C squared. So 121 plus 9, which is 130. So 130 is going to be C squared. But remember, I'm trying to find this distance by itself. Right now I have the distance squared. So what do I have to do to both sides? That's correct. I got to square root both sides. So I got to square root both sides. So this is C is equal to the square root of 130. All right, I'm going to show you in the second one when I'm using the calculator whether we need to simplify this or not. Because remember, whenever you have a radical answer, you do need to simplify it. So if you can't take the square root of something, unless they say round to the nearest whatever, all right, you have to simplify it. So I'll check it when I do the second one. But that's Pythagorean theorem. So Pythagorean theorem is make a triangle, right? Opposite from the hypotenuse, from the 90 degrees is the hypotenuse. A and B doesn't matter as long as you have C in the correct spot, and then solve the equation. Let's take a look at distance. Distance is even easier in my opinion, but sometimes you guys have a problem with it. So you guys, I'll let you decide. So the very first thing you're going to do is label the points. This is x1, y1, x2, y2. Okay, make sure the ones are together and the twos are together. All right, now all you gotta do is plug them right into the distance formula like you see it. So I should have x2 first, which is what? -1, minus x1, which is what? 2. Okay, squared, plus y2, so the second y value, -4, minus y1, which is 7. And you put this whole thing in the calculator. When you put that whole thing in the calculator, you're going to get the square root of 130 or some decimal. Now, I'm going to use a calculator to see if we can simplify this. If the question was round, you would round. You wouldn't have to worry about simplifying. But if the question didn't say anything, they want it in simplest radical form. Okay, so let's go over to the calculator. Let's see if we can. Now we're going to transfer exactly what you have in our notes into the calculator. Please make sure that you type in exactly what you have written down. So I'm just going to do the general formula. So parentheses, squared, and then inside this parentheses, they're negatives, right? All right, so now you're just plugging in the numbers. x2, x1. So x2, -1. x1, 2. y2, y1. So y2 is -4. y1 is 7. All right, is this rational or irrational? And how do you know? All right, so this is irrational because it is not repeating, it does not terminate, and you cannot write as an integer or fraction. So which means they're going to do one of two things. Either they're going to say round to the nearest blah, 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 or they're going to say write it in simplest radical form. So I'm going to show you radical form because rounding, we've already talked about, you can just type in round with a parentheses, whatever it is that you want to round. So copy paste, comma, and whatever they say. If they want one number after the decimal, you type in 1. Two numbers after the decimal, well, that didn't do 2. Oh, I guess it's 40, that is 2. 3 numbers after the decimal, 3. 4 numbers after the decimal, and so forth. All right, so the nearest 10th, so let me write this down. Nearest 10th, 1 0, 1 number. Nearest 100th, 2 zeros, 2 numbers. Nearest 1,000, 3 zeros, 3 numbers, and so forth. All right, so we know how to round. So we're now looking at how do I simplify a radical. So what you're going to do is you're going to copy and paste everything that's underneath the radical, because that's what's making it this irrational number. So I get 130, right? So what I'm saying is I can take this and type in 130, and I'm going to get the exact same thing. Okay, so the question is, how can I simplify 130? So remember, you have to take the prime factorization of it, break it all the way down, and then see if you can make any books. So how do I break it down? We're going to start, depending on what kind of multiplication factor you know, I'm going to start at the very bottom just in case. So I'm always going to check 2, 3, 5, 7, 9, and so forth. So let me check 2. It works. So what this is saying is, and keep an eye on this decimal here. If I say 2 times 65, this should not change. So 2 times 65. See? Same number. Did not change. So I'm breaking it down. How do I break 65 down? So we're going to check it again. So 65 by 2, that doesn't work. So we're going to check by 3. That doesn't work. We're going to check by 5. That works. So I can replace 65 with 5 times 13. So I'm going to say 5 times 13. Keep an eye on this number. Did it change? It did not. So it's still good. Can I break 13 down? No, because it is already a prime number. So I have this broken down. Do you have any books? Do you see any books? No. So because I don't see any books, that 130, 2 times 5 times 13, right? The 130 is the simplest I can write it down, but you do have to check, because if it can be simplified and you don't simplify it, you're going to get the question wrong. So this simplified is the square root of 130. But you see, 2 ways of getting the exact same answer. Distance formula, label and plug in. Pythagorean theorem, draw a triangle, and then do a squared plus b squared is c squared. All right, so let's take a look at example 2. A quadrilateral. So what does quad mean? Quad is 4, right? Like quad, right? So 4. So 4 sides has vertices at 1, 2, 3, 4. That makes sense. 4 points, right? Find the lengths of AB, BC, CD, and AD. Find the lengths of the diagonals. Then ask what quadrilateral it is. So I'm kind of just preparing you for geometry, but I'm going to do the algebra, because in geometry, they're not going to go over distance formula and Pythagorean theorem. They're just going to expect you to be able to answer this question after they show you the properties of quadrilateral. So let's go ahead and do it. Again, you choose whatever method you want to do. How about I do 2 of them on Pythagorean theorem, and then I'll do 2 of them in distance formula. Now, here's the thing about Pythagorean theorem. There is no coordinate plane, right? But that's okay, because I can still do it. This is AB, so this is A and then B. So these are my 2 points. So again, as long as I have a rough idea of where they are, so say this was my coordinate, right? I should have -5, 1, -5, 1 right here. So this is -5, 1, right? So roughly, so I'm just doing a little sketch. Then B is -4, which is just before that, 4. So somewhere over here, this is B, this is -4, 4. So once again, you can use distance formula or Pythagorean theorem. So this is my side right here. So I'm going to make a triangle. And I probably should have done this a bit bigger. Let me do this a bit bigger so that you can see. All right, so I'm going to make a triangle. So the question is, for Pythagorean theorem, is what is this and what is that, correct? That's how you're going to know. So this distance here is my x. So how do I go from -5 to -4? Do you agree that it's one space? From -5 to -4. How do I go from 1 on the, now this is the y-axis, right? How do I go from 1 to 4? Do you agree that it's 3 spaces? So you don't actually have to draw it completely in order to do it. So if you find this difficult, you can just plug these in right into the formula. But I'll stick to Pythagorean theorem. So a squared, which is 1 squared, plus b squared, which is 3 squared, right, is equal to c squared. So that's 1 squared is 1. That's 9. So this is 10 is equal to c squared. And of course, we are not looking for c squared. We're looking for the square root. And c in this case is AB. So AB is the square root of 10. Okay. Now, distance formula is faster because at this point you're just going to plug it in. I still like Pythagorean theorem. That's the way I like to do it. But let's see. We're going to go BC. So BC is I'm using these two right here. All right. So I'm not going to label it here because if I'm using more, I'm going to need some more labels. So I'm just going to actually write it down. So it's -4. 4 is B, and then C is 2, 2. All right, again, if you're using distance formula, what are you going to do? You're going to label x1, y1, x2, y2, and you're plugging right into this equation, okay? So let me zoom out so we can still see it. So square root, so this is a BC. So BC is the square root. Maybe this is actually less writing. BC is the square root of x2. So what's the second x? 2. Then minus x1. What's x1? -4. Make sure you don't combine those. Leave it just like that. The calculator will take care of it. Then squared plus y2. Y2 is 2 minus y1, which is 4 squared. And you're going to put that whole thing in the calculator. So I'll do this calculator portion at the end. Let me just do all of them. So that's BC. Next one I'm going to do is CD. So I'm going to write my points down. So let's write my points. CD. So C and D. So right here. So 2, 2, and 1, -1. All right. And this is CD. Okay. So again, go ahead and label. So this is going to be my first X, my first Y, my second X, my second Y. All right, so CD is going to be the square root of, and again, you're just following this formula. So CD, this formula says square root of x2. I'm going to have to zoom out just a little bit. All right, so what's x2? Yep, 1, then a minus sign, then x1. What's x1? 2, then squared, then a plus sign, then y2. What's y2? -1, then minus y1. What's y1? 2 squared. And you're really going to just stick that right into the calculator, okay? We'll do the last one and then we'll stick it all into the calculator. So the last one is I'm looking for AD, right? So the two that I need is A and D. So let's put that where? And put it on the side here. All right, on the side here. So this is going to be -5, 1, and D is it's +1, sorry, -1. All right, so again, this is AD is equal to the square root of, all right, now we're going to label. All right, so this is x1, y1, x2, y2. And all we're going to do is put it right in here. So starting with, let me bring my formula right back so I can see it. Square root of x2, so second x is 1 minus x1 is -5. So again, don't drop that negative because of the minus sign. So you just put in whatever x1 is. If it's negative, it stays negative. All right, then squared plus y2, which is -1, minus y1, which is 1, then squared. And you're putting that whole thing right up in the calculator. So let's go ahead and put all of those right in the calculator. All right, so again, we're just going to type in exactly the formula in here in general terms. So the 2 parentheses squared plus another 2 parentheses squared. And then in here, there's a minus sign in both. And now we're just plugging in the numbers. So we're going to do this a couple of times. So Control C, Control V, right? Just so I have all the numbers I'm putting in. So looking for BC, I have 2 and -4 on my paper. And again, please make sure transferring exactly what you have on your paper. Here I have 2 and 4. So that's my answer for BC, but it's a decimal that doesn't look like it's a terminating, but it's not rational, which means I might have to simplify this if they don't say round. And does this question say round? It does not. So I'll come back and simplify once I put all of them in. All right, next one is 1, 2, CD, -1 and 2. Again, that's not rational, right? Because it is not repeating, it doesn't terminate. All right, it cannot be written as a fraction of integers. And AD, which is 1, -5. This one is -1. Always double check to make sure that what you have written down is what you're typing in. So it looks like these are the same. Okay, and let's put in that first one that we did, the square root of 10. Square root of 10 that we did using Pythagorean theorem. And looks like we got two sides of the same. So if you had to guess what kind of four-sided shape this is, what would you guess if you saw that two sides are the same? Okay, just, putting that out there. All right, so let's simplify this in case they ask us to. So remember, if you're simplifying this, we'll start with the one on the top. Take everything except the square root, right? Because that's what we're simplifying. And make sure that the answer doesn't change. So it's supposed to be the square root of 40. Okay, so it's supposed to be the square root of 40. All right, 6.342, is that what we have? Yep. All right, now, while you're simplifying, this should not change. So break down 40. So remember, if you don't know multiplication facts, you always check in 2, 3, 5, 7. So check 2 first. It works. 2 times 20. So you're going to replace that in there because you haven't changed anything. See that? Keep an eye on that decimal. Hasn't changed. All right, break down 20. So we're going to check it 20 by 2 as well. 10. So this works. So we're going to say 2 times 10. That decimal has not changed. So you're still good. Check 10. All right. Yep, it works. So we're going to replace this with 2 times 5. All right. Can I break down 5? No. So this is it. And you see the decimal has not changed. This is what I have. Now we're just messing around with this and we're going to see what happens, right? So do you see any books? Yes. I have a book of what? 2. So 2 cards make how many books? 1. 1 book outside, correct? Take out this because that's in the way. Did it change? No. Did you see any more books? No. So you combine these numbers back. So 2 times 5 is what? 10. And you see how you still have the same number? So 2 radical 10 is this answer and this answer. Now we're going to have to simplify this 3.16 with this radical 10. So again, remember, it does not change, right? So it can't change. So break 10 down. 2 times 5. All right, didn't change. All right, but do you see any books? No. So this one is as simplified as it possibly can be. So these are your 2 answers that you're going to write down in your answer sheet. All right, so I'm not going to do this whole question because when you get into geometry, you're going to cover this. It is not enough to prove. So you see these are 2 sides of the same. I've got these 2 sides of the same, these 2 sides of the same. What 4-sided shape can you think of that those sides are the same? So this ends up actually being a rectangle. Right? Opposite sides are the same. And we can check that. So let's label this A, B, C, D. So AB is the same as DC. So AB, which is radical 10, is the same as DC, which is the same as CD. So CD, which is also radical 10. So they're both radical 10. And then these 2 sides are the same. So AD and BC. So AD is this, and BC is this. So opposite sides are the same. In geometry, it's actually not enough to just prove that opposite sides are the same because it could be a different shape. What you actually have to do is also prove that these diagonals are equal. So the diagonal AC is congruent or equal to the diagonal BD. All right, so once you find those are all the same, then this would be a rectangle. All right, now because this is not geometry, I'm not going to go into all of it, but this would be either Pythagorean theorem or distance formula to prove that those 2 are congruent. And the word congruent means equal. All right, so it is a rectangle because opposite sides are equal and the diagonals are the same. But you'll do that part in geometry. This math part is your expectation that you'll know how to do it because the question in geometry is what shape is it and how do you know what you know? So they expect you to be able to do this part without any help from geometry teachers. And all they're helping you with is what quadrilateral is it and how do you know? So algebra is within geometry. All right, so let's take a look at example 3 and 4. You guys are actually going to go ahead and do example 3 and 4. Use Pythagorean theorem to find this one and then use distance formula to find this one. Let's practice.